Welcome students. This is KL Kiran Kumar, JL in Chemistry, Government Junior College, Rajendra Nagar. Today our topic is atomic structure. Atom, the word atom derived from the Greek word atomio, which means non-divisible. Atoms are the fundamental building blocks of matter, that is, solids, liquids and gases. Dalton's atomic theory. All matter is made up of tiny, indivisible particles called atoms. Atom is the smallest particle of element. Elements are made up of identical atoms. That is, same atoms combined to give the elements. Whereas molecule is the smallest particle of compound. So what is the difference between compounds and elements? Elements are made up of same atoms, whereas compounds are made up of different atoms of the different elements. Compounds are formed when the atoms of different elements combine in fixed proportions. That is, compounds are that one which combine the atoms of different elements in the fixed proportions. Atoms are neither created nor destroyed in chemical reaction. So what happens to atoms? The atoms will rearrange in the reaction. So if you observe the atom contains subatomic particles, that is, electrons, protons and neutrons are the subatomic particles. We all know that after the Dalton's atomic theory, these subatomic particles are discovered by the different scientists by different experiments. So first if we observe discovery of the electrons. So this is discovered by J.J. Thomson. So to discover the electrons, they use the cathode ray experiment. So in the cathode ray discharge tube, the current of high voltage. So we can observe that in this slide, the current of high voltage is passed through the discharge tube. What we are seeing on the screen is the discharge tube with high voltage current is passed at low pressure. Whereas we in the low pressure and high temperature will get the blue color rays which will pass from the cathode electrode to the anode, towards the anode. So the cathode ray starts from the cathode and move towards the anode. They produce phosphorescence on certain salts like zinc sulfide and also fluorescence. They blackens the photographic plates. In the absence of the electrical and magnetic fields, these rays travel in straight lines. Cathode rays are deflected by magnetic and electrical field, showing the particles are electrically charged. The direction of deflection shows that they are negatively charged particles. That's why they are called electrons. So that is, electrons are negatively charged particles. So cathode particles are also called electrons, we can simply say. So the characteristics of cathode rays or electrons do not depend on the gas which we are taking in the discharge tube. And the nature of the gas also, it does not depend. Electrons are basic constituents of all atoms. So discovery of electrons by the discharge tube experiment, as we have seen, this is done by the J.J. Thomson. So if we see next fundamental particle, that is subatomic particle, is the proton. So how the proton has discovered from the atom, if you observe. So it is a positive ray or canal ray experiment, we can say. By using a discharge tube containing a perforated cathode, this is done by the Goldstein in 1886, found that some rays passed through the holes in a direction opposite to that of cathode rays. These are also known as anode rays because they start from perforated anode and moves in the opposite direction. And these rays are made up of positively charged particles known as protons. Unlike cathodes, cathode rays is different from the anode rays. So anode rays are not just like cathode rays, and these are positive in nature, positive rays, and the characteristics of this rays depends on the gas in the tube, whereas the cathode ray does not depend on the gas. That difference you have to notice. The charge to mass ratio, E by M ratio it is called, charge of the particles by mass of the particles is not constant for this rays because they depend on the gases. So this is E by M ratio is found different for the different gases used in the discharge tube. The deflection of the positive rays under the influence of electric or magnetic field is smaller and opposite to the direction of the cathode rays, opposite that of the cathode rays. So for the same strength of field. What here he is explaining, so here the anode rays will move slowly but opposite like the cathode rays, depends on in the same strength. So this shows that the positive rays have greater mass than that of electrons. That is, protons have more mass than the electrons. So if we observe the difference between the cathode rays, that is electrons, and anode rays, that is protons, so we see some properties like charge. Negative charge for cathode rays, whereas positive charge for anode rays are canal rays, that is positive rays. Whereas magnitude of charge if we observe, so for the cathode rays always it is negative, -1. Whereas for the positive rays or protons, that may be positive +1 or sometimes +2 or +3. Whereas mass if we observe, this is having definite value. Mass of the electrons are definite value and very less negligible mass we can say. Whereas positive rays or canal rays, the mass is going to be variable depend on the gas filled in the discharge tube. So like the same, another property if you see, charge to mass ratio, the cathode rays will have definite value, whereas the value for the positive rays will variable but depends on the gas filled in the discharge tube. So notice that. So we will be understanding the difference between cathode rays and anode rays, that is electrons as well as protons. So whereas the electrons are discovered by the J.J. Thomson and positive rays, that is protons, are discovered by the Goldstein. Now the another particle, that is subatomic particle, neutrons. So these neutrons, the name itself says that these are the neutral particles. So after discovery of electrons and protons, Rutherford 1920 has predicted the existence of a neutral fundamental particle. So he just predicted that one more particle may be present that is having neutral charge. In 1932, Chadwick bombarded, means he interacted or bombarded the element like beryllium, that is having 4 atomic number, with a alpha particle. Alpha particle is a positive particle, mostly helium atom. And notice the emission of the radiation having the following characteristics. Means, so Chadwick did the experiment bombarding the alpha particles on the beryllium, and he found some characteristic rays has been came. That characteristic properties we are going to concentrate. Now you see the first point, the radiations are highly penetrating. The radiations which are coming after bombardment is highly penetrating. The radiations are unaffected by the magnetic and electric field, which shows that the particular particles are not going to affected by the Electric field means no charge to these particles. Electrically neutral, we can say. It was found to have approximately same mass as the protons. That is nearly same mass to that of the positive particles. So here point is the particles which came out that are electrically neutral, they are having mass near to the protons and they are having the penetrating power. The name neutron was given to the subatomic particle. So if you observe, it is denoted by small n or N01. Bombardment of beryllium by alpha particle result in formation of the carbon and neutrons are emitted. So that is alpha particles when they bombard or hit the beryllium, you will get the resultant one is carbon and also neutrons. Those neutrons are electrically neutral. That's why they are not having charge but mass is equal to the protons. So at present, these are a number of evidences which confirm that like electron, proton and neutron is also fundamental constituents of atom. That means except the hydrogen will have negligible neutrons, that is we can say no neutrons for the hydrogen. Except the hydrogen, all the atoms of the elements contain fundamental particles, constituents. Those are electrons, protons and neutrons. So in the atom, basically electrons with negative charge, protons with positive charge and neutral charge particles are present. So up to here, so discovery of the fundamental particles, that is subatomic particles. Like electrons are discovered by J.J. Thomson, whereas protons are discovered by Goldstein and neutrons are discovered by Chadwick. Those are the fundamental particles of the atom. So how these fundamental particles are arranged in the atom. Those arrangement by different scientists with different models. So the familiar models we are going to concentrate now. So how these fundamental particles like electrons, protons and neutrons are arranged in the atom, explained by the atomic model. So first atomic model is atom. J.J. Thomson has explained the one of the atomic model. So that is this model, he assumed the atom is going to be spherical. Thomson is given this proposal in 1888 and spherical shape he assumed for the atom, in which the positive charge uniformly distributed throughout that spherical shaped atom. Positively charged one is uniformly present. The electrons, the negatively charged electrons are embedded in the positive charge, just like in the watermelon. So the redness of the watermelon is like the positive charge, whereas the seeds, black seeds, electrons embedded. So that is the atom containing total positive charge and inside that positive charge the electrons are present. This is the model is also the plum pudding or raisin watermelon model. So this model is mass of atom uniformly distributed throughout the atom. So what are the drawbacks of this model? This model is the watermelon model by J.J. Thomson. So this is not accepted by the scientific society. Some drawbacks are there. It could not explain the scattering experiment carried out by the Rutherford. So alpha ray scattering experiment is given by the Rutherford and it is not explained. That is, this model unable to explain the alpha ray scattering experiment by the Rutherford. So what is that model? We will see Rutherford's alpha ray scattering experiment. If we observe, alpha ray scattering experiment is given by Rutherford here in the year 1909. In this experiment, a very thin foil of gold, you can see that on the screen, a yellow color one, thin foil. This thin foil is as much as very thin, 0.004 nanometers. Is fixed in a position that this screen is bombarded by the fine stream of alpha particles. Alpha particles are positive particles that is mostly helium, positive particles. Then a fluorescent screen is arranged, that is zinc sulfide screen is arranged behind the gold foil, where the points are recorded which were emerging from particles. That is, when the alpha rays are going through the gold foil, they hit the screen backside. That screen is made up of the zinc sulfide screen. That is a salt. So polonium was used as a source of the alpha particle. So polonium is a radioactive element which will decay and produces the alpha particles. Those alpha particles are straight away bombarded onto the gold foil. So, but these particles will move through the gold foil. Most of the particles entered. So, what the experiment has given some observation. So, if you see the observations, most of the alpha particles are 99% of the alpha particles passed through it. It is they are passed through it without any deviation. Means most of the particles, positively charged particles, entered through the atom and they hit on the zinc sulfide without deflection. But if you see 99% of the particles are passed, means the atom is having lot of space. So some of the alpha particles, very less, was deflected through small angles. So not much big angle. So very less particles are deflected. Whereas very few, that is very few particles are deflected in 180 degrees angle. Very less, very few. So that is these observations from the alpha ray experiment given the what is the atom, how this atom containing the subatomic particles. So here an atom must be extremely hollow, because lot of 99% of the alpha particles passed through it. So the empty space is much more and most of the particles are passed without any deviation. Very few particles are deflected. We are saying that very few particles to a large extent. This indicates that they must be a very heavy and positively charged body in the atom, in the middle of the atom. That is the nucleus, which does not permit the passage of positively charged particles. So here what we are understanding, the particle is, the atom is having a spherical shape. Lot of particles are moving. Alpha particles are moving, means the space is more. Only one out of the thousands of the particles are deflecting back. That indicates a heavy mass, positively charged mass is present in the middle of the atom. So that is called nucleus. So here, because the number of alpha particles which are at 180 degrees is very small, therefore the volume of the positively charged body must be extreme of the total volume of atom. So if the atom is very big, the middle is very small, nucleus is very small, and means comparative to the volume of the atom, nucleus is very small in the middle. This positively charged body must be at the center of the atom, which is called nucleus. So it has been found that the radius of the atom is in the order of 10 power 10 meters. So atom radius is 10 power 10 meters, while the radius of the nucleus is 10 power 15 meters. Thus, if a cricket ball represents a nucleus, if you see the ball as a nucleus, around the nucleus 5 kilometers volume is the atom. Means if a ball is the nucleus, means around that 5 kilometers, if we assume that total space comes under the atom, that means the atom is very, very bigger than the nucleus. So, like this, atomic model, Rutherford alpha ray atomic model explained about the atom, which is almost accepted. But main features of the Rutherford atomic model, if you observe, the positive charge and the most of the mass of the atom was densely, means thickly, densely concentrated in extremely small region. The very small portion of the atom, that is nucleus. So what is saying according to the Rutherford model, is saying that the nucleus is very, very small in the atom comparative to the atom. It is a mass that is positively charged body which is present in the middle of the atom. The nucleus is surrounded by electrons. The nucleus with a very high speed in circular path or orbits called orbits. So here observe students, what is happening? The atom contains nucleus. The nucleus is the positive charge. That positive charge around that in a fixed path like orbits, electrons are revolving. So this if you observe, it is comparing with the solar system. Center of the solar system like sun. So if we assume sun as the nucleus, the planets are revolving around the nucleus in the orbits. Like the same, electrons are revolving around the nucleus. So that's why Rutherford model is also called the solar system model. Okay. So the Rutherford model of atom resembles the solar system we are seeing, in which the nucleus plays the role of sun and the electrons that are revolving like planets. Electrons and the nucleus are held together by electrostatic force attraction. Here the electrons are not going away from the atom. Like the same, planets also not going away from the sun. Why? Because there is a force of attraction between the nucleus and the electrons, that is called as electrostatic force, which includes centrifugal and centripetal forces, which will maintain the electrons. So that is a main features of the Rutherford model of atom. Whereas this Rutherford model of atom is accepted, it is also having some drawbacks. Drawbacks is that one which are unable to explain or unable to prove by the Rutherford. So what are the drawbacks of this Rutherford model? According to the classical mechanics, if you see the classical mechanics, any charged body in the motion, it has to undergo the influence of attractive forces should radiate energy continuously. Means that it has to lose the energy. It has to lose the energy, like an electron also should lose the energy, and it has to come and fall in the middle. When the electrons, if they fall in the middle, they will collapse. But atom is stable. It is not going to destroy, not going to be created. It is neither created nor destroyed, we know. That means atom will not destroy, but this point is not explained by Rutherford. Means any charged body should lose the energy. So, but electrons are not losing the energy. They are not falling in the middle, that is in the nucleus. So, this is unable to explain. If this, so the electrons will follow a spherical path and finally fall in the nucleus. So, the structure would collapse. He is saying the same. Yes, it is not explained. Remember that the in the drawback, this is very important point. The electrons like charged particle, if it is continuously moving, it has to lose its energy, and spherically, that is, it will spirally come and fall in the nucleus, but it is not happening. This is not explained by the Rutherford. If it says nothing about the electronic structure of the atom, electronic structure, that is how electrons are distributed around the nucleus and what are the energies of these electrons, means electronic, how the electrons are arranged. So in first orbit, how much it is arranged, and second orbit, how much it is arranged. So it is, the Rutherford model is unable to explain about the arrangement